Anyways, so what I'd like to do today is just go through some of the stuff that we've done within the ABMI, and I'll stress up front the work that's on birds. We've used data that ABMI has collected, but we've also, the information incorporates the stuff that others collect as well, and it makes total sense. There's no sense having data and not using it. So we incorporate whatever data we can with partners, and there's folks in the room who have contributed as much as I have, more than I have, to the information I'm going to present here today. So it's ABMI, but it's ABMI plus. So I'll start with a little bit. I'm going to start with 5 or 6, 10 slides on ABMI. Then I'm going to push it a little bit further into some of the outputs that we've been able to create that I think are neat. And finally, end with just some thoughts on the future, if you wish. So first, back to the ABMI. The goal is to be able to identify where birds, in this case, but it's critters, live throughout the province, and how they're associated, how their abundance changes amongst habitats, and understand the degree to which things that we as people do affect those birds. So that's the goal, the overall goal of the ABMI. The program was initiated back in 1998. There was a development period of 4 or 5 years, then a pilot stage from 2003 to 2006, and then the program was really initiated in 2007, and the data collection started from ABMI at that stage. We are just now entering revisiting sites, so starting in 2015, we're starting on the revisit schedule. The program, and these points on the right-hand side, are the places where ABMI has visited. But I stress, there's a lot more data in the analysis that I'm showing than just these points. The goal of the ABMI really is fourfold: to talk about cumulative effects, the abundance, distribution, and trend over time in critters, including birds. Talk about these stressor response relationships. How do the things we do as people change them? Understand how to apply that information to planning, both in the upfront piece of what do we want on the landscape, how can we take this information to help with better planning, and on the back end, did we achieve what we wanted? So the monitoring helps us evaluate, did we achieve things? And finally, the goal is about communications, providing tools that folks can use, providing information that people can use, and recently we've got into how do we involve citizens in data collection. Those are the main tenets of where ABMI is. The critters that we work with has birds, but it has many other species as well. And so it's not just a bird program, it's meant to span the whole range of biodiversity. What folks tend to think, though, is mostly about field sampling, but it isn't just field sampling. The information that's collected has to come back and be identified. In the case of birds, the recordings have to be identified. But in other critters, other types of biota, there's a whole bunch of processing to identify the species. Then there is all the pieces about data checking and validation and QC and so on. That's not trivial, and it takes a fair bit of work. Then analysis and reporting. So we tend to think about data collection, but it's not just data collection. It's data management to producing the information that folks can use. For the case of birds, from 2007 up to 2014, we used these omnidirectional microphones and used what you'd typically think of as a point count. So ordinarily or historically, folks went out and stood at a place and listened for 10 minutes and recorded all the species, all the birds that they heard. With a microphone, you go out and you set it up for 10 minutes, you record everything for 10 minutes, and then move around, and you can do 8, 10, 12 points in a morning. So we had it set up so that folks would do this 9 points at every site in a morning of sampling of birds with these omnidirectional microphones. This is the ABMI sampling. I would stress again, there's integration from other places in the data set that I'm going to present. So this is just how the ABMI did their sampling. Starting in 2015, we moved to these ARUS, automatic, the machine that turns on at set times, records, then turns off and waits and turns back on again later. We started with SM2s, which were a bit clunky and finicky. Then there was an SM3, which was way more robust, but weighed a ton. And now we've got some SM4s that are light and robust, which is kind of a nice compromise. But this information really does give you ability to do different things. So instead of 9 point counts now, we set them out at 4 stations, but they record from the start of March through to the end of June and 7 or 8 times a day. So it's just increases the span of data from a diurnal sense and from a seasonal sense. And that's the basis then for the information that's collected with ABMI, but I stress other folks have contributed greatly to the information we're using. Along with the data on birds, there's information on the types of human footprint, the things that happen at the sites we surveyed. So within the ABMI, we've created these maps of human footprint throughout Alberta. It's meant to integrate all of the different types of human footprints, so energy and forestry and agriculture and urban and so on, and just lay them on top of each other to create a combined map. To a large degree, to some degree, we can take existing GOA maps that others have produced, and simply just overlay them. But there's some things, about half the human footprints, there are no maps to overlay. So in that case, it is go back to a satellite image and digitize the human footprints, and then create those maps and overlay them. But we can end up then with a wall-to-wall map, and then we do very detailed human footprint classification around each of the sites that are surveyed. In addition then, also create vegetation maps for each of the places that we visited, plus a coarser vegetation map for the rest of Alberta. And this really is a Frankenstein map. What we have in Alberta isn't one classification, one vegetation system that's good everywhere. It's a series of different types of information that was created for a variety of different purposes and put together in a Frankenstein sense to create a continuous surface of vegetation throughout the province. It's as good as we have. It doesn't mean it's perfect, but it's as good as we have. You can end up with 20 or so upland vegetation types and 5 or 6 lowland, wetland vegetation types. The upland vegetation types, at least for forest perspective, you can then get year classes within them. So you end up with 60, 70 different classes of vegetation wetlands that you can use as background in doing the model. So one can get present condition. We also created what we call the backfill layer, which is just the vegetation that would be expected if there was no human footprint in the area. A linear feature is pretty easy. You just say, well, what's on both sides of it? And you nibble it in. You say, well, that's what we expected there if there had been no human footprint. Polygons takes a bunch of logical rules. I mean, we only cut big trees. So when you're filling in a cut block, you'd better fill it in with big trees. So you use logical rules for the polygons, and for the linear features, just nibbling. And you can create then this reference vegetation. We use the information then. I'm going to show an example here for red starts. We use the information to model habitat associations. So the map on the top just shows the points that have been surveyed, little X's, and when a red start was detected, it's a big red dot. The maps on the bottom are the human footprint of vegetation. If you know the human footprint of vegetation, you know the abundance of the bird when it was detected, you can create this habitat suitability model. And so each of the groups are different habitat types. These ones that are in forest have different age classes. So 0 to 20, 20 to 40, 40 to 60, and so on. So it's then just a model that predicts what is, so it's based on real data, what is the expected abundance of that critter in each of the different habitat types. The neat thing about that model, once you have it, and if you have these two maps, you can predict what is the expected suitability of habitats, in this case for red starts, in every pixel throughout Alberta. So it's just taking this information and these two maps and predicting what is the expected suitability of each of those pixels for red starts. With red meaning we expect habitat to be very suitable, and blue meaning you might find them, but it's really not very suitable habitat for red starts. And you can do that under reference conditions, you can do it under current conditions, And the difference between the two really is the effects that we as people have had on the habitat suitability for redstarts. So it's a cumulative effects map. It's just a difference map between reference and suitability. What's also neat about this map is you can summarize it in a different way. You can say, based on the map, and this summary that I'm doing on top of the sector, just think Edmonton and north. So this is in the north. What is the effects of different sectors on that critter? The scale along the bottom is the amount. So there's about 2-3% of northern Alberta has been affected by agriculture, and agriculture has a negative effect on redstart. So in total, agriculture has decreased the habitat suitability by about 2%. And forestry, it actually has a bigger area in northern Alberta, 6 or 7%, but it has a positive effect on redstarts, and it increased the habitat suitability for redstarts by about 10%. So one can then evaluate what is the effects today of what different sectors have done on each of the critters. And some of the things that we do have relatively small footprint, so they have, even if they have big effects, they have relatively small effects on the critter. You can do this for redstarts. You can do the same damn thing for kinglets. You can do it for any species that you have reasonable data. And that's what we did. So there's about 800 species. Not that these aren't all birds. There's only about 200 birds that we have the information for. But you can create this type of information for each of the species where you have reasonable data. And this information then is available on the ABMY website. You can just go on and click through any of the species you're interested in. It's a really neat resource. It's actually something that is quite doable, and I would say is the envy of many jurisdictions around the world. To have it, to be able to look at it, and to be able to think about things on a species by species basis. Not only can you do it though for things that you have reasonable data, if you don't have reasonable data, you can still do something. So with broadwing hawk, we have relatively few detections. We can't do complex modeling, but you can tell kind of where it lives. It lives in central Alberta, across the band across central Alberta. It likes deciduous mixedwood, and most everything else it really isn't found much in. That's not a lot, but it's a way more than nothing. And we have that for 1,500 species. This information, you can find it there. If you just go onto the ABMY website, it'll lead you to these websites eventually if you want to go and look at it. And I'd encourage you to, not just for birds, but for any species that you care to look at. If you get nothing else about what I'm talking about today, if you just stop there, turn it off, good, I can handle that. What I'm going to say next is neat stuff, or I think it's neat stuff, but it's not, the main message has already been given. So this next part is just places where I'd like to push the data a bit further. I said, given that we have information on all these species, what can we say about old forest species? And I thought, it's going to be a piece of cake. You just mix them all together and you're going to get a great, neat pattern. And to some degree, that's true. So if you use brown creeper as an example, they show the pattern they expect. I mean, you get more brown creepers in old forest. They're throughout the southern boreal. They have these nice sector effects. Forestry, because it takes out the big old trees, has a negative effect on brown creepers. You can look to see how brown creepers are affected between what was historic or reference and present. It all makes sense. If one then takes it and sums up not for brown creeper, but across old forest specialists. So this is just a list that I got there. I didn't make it up, but it's a list of old forest species. You can do the same thing. Where's the abundance of those species? Where's the pattern of their abundance? And sure enough, older forest has more of them than younger forest. But look at those error bars. My gosh, those species are all over the map. And they're kind of in old forests, but they're sure in a lot of other forests too. The sector effects, I mean, forestry has a slight negative effect, but it's not near as great as I was expecting. And if you look at the overall distribution of the map of those group of species, I mean, sure enough, they tend to be most abundant in forests, but they're not really that most abundant in old forests. This is a group of species that folks are saying are old forest species. Now, it's kind of there. If you squint a lot, you can see some patterns, but it sure as heck ain't near as obvious as the one with brown creeper. And I'd say it's probably because of the groups that we created. If you go back through and look at those old forest species, and I just did this myself, so take it with a grain of salt, but those 8 or 10 that I highlighted in red, those are old forest specialists, in my mind. Those are ones that really do show strong patterns to old forest. The ones in orange kinda are old forest specialists, but each one of them has something else that's odd about it. They found somewhere else, they do something else that's odd. So they like old forest, but there's other things going on. The ones in gray, you'd have to squint pretty hard to call that an old forest specialist. Now they live in old forest, but some of those you'd squint pretty hard to figure out that it was an old forest specialist. And I think what that highlighted as I went through and did this work was one then needs to be conscious about what you want to get out of your grouping of species that you're doing. There's nothing wrong with grouping them, adding them up, taking averages, but be conscious of what you want to get, because how you group the species will determine where you end up. I just found that neat. So you don't have to take any of that home if you want. Another thing that I found neat, take the same data, and all this map then says is in every pixel, let's look at what is the community similarity between pixels. I didn't do any of this work, guys. So I didn't do nothing here. I'm just presenting it. Some folks that I work with did this. But what is the similarity between pixels for birds? The more similar the color, the more similar the bird community. And you can see that there's a bird community that lives in the prairies, a different bird community that lives in the mountains, and a third bird community that lives in the boreal. There's nothing neat or new about that. It's sure nice to see it in a map. What's also neat is when you get into the boreal, as soon as you get into the highlands, you pull in a whole bunch of the community that lives in the mountains. Neat. In the parkland in the Peace River, it actually shows more similarity to a bird community from the boreal than it does to a bird community on the prairies, whereas the opposite is true in the central parkland. So this is just simply another way of looking at how bird communities vary throughout space. This same map, if instead of looking at bird community you look at richness, you find that the richness of bird community is in that transition between parkland and boreal, usually about the northern edge of the dry mixedwood. That's where we go to find the richest bird community. It's simply another way at looking at this data, which is summarized from species by species information. And if you looked within any natural region, those areas that have the most unique bird communities are the transitions between habitat type. So this is central mixedwood, there's a highland. The transition between the central and the highland is where you find the most unique bird community. Now, much of this makes sense ecologically. But it's neat to see it, or at least I think it's neat to see it. All of this information can be downloaded there, looked at it on that website, and if you just go to ABMI website, you can eventually work your way through to this. I'm going to end with some thoughts about the future, and that's the ARUS stuff. So these recorders really are going to change how we work with birds. It's changed the system of how we collect data. It is no longer necessary for a person to go out at 2 o'clock in the morning and listen for 3 or 4 hours in the morning. You set these things out whenever. You can set them out in September if you want and pick them up the next September. You can program them so that they collect the data at set periods of time. You can end up with gigabytes, terabytes, probably whatever the bigger word than terabytes of data are. There is a lot of data that can be collected. And this will change how we analyze bird data. Interpretation, though, becomes the challenge. It's still to have somebody interpret the information from 10 minutes of a recording takes just as much time as interpreting 10 minutes standing in the field. In fact, it takes a little bit more, because it probably takes about 20 minutes to interpret 10 minutes of a recording. But if we move, so presently we have humans interpreting with computer assist to make it a bit more accurate. If we move to computers interpreting with humans doing QC, we may be able to use lots more of those thousands of minutes that we're collecting. And throw in citizens. Even I, when I can't hear anymore, can put out an ARU. You take 2 screw nails, put it in a tree, and it's there. It's totally programmed. Somebody else did all the hard work. It's got a card in there. It's got batteries that work just fine. I go back 6 months or a year later and pick it up. That information is there, and anybody can do it. Not just the people in this room, but anybody can do it. And that really is a game changer. That means that we can collect data throughout Alberta, throughout the world, for very cheaply. If we can get these units in the hands of folks that want to put them out, we're going to have petabytes. We're going to have whatever the bytes are very soon. And this will change the questions that we're asking. We'll be able to talk about these habitat associations, but we'll be able to talk about other things in meetings like this very soon. I think that's it.